Hi everybody, welcome to DSC at UW's Get Started with DSC series of workshop. Today we're going to talk about Git. That's a CLI, command line interface. So without further ado, let's talk about what DSC wants to achieve with this series of workshops. So basically our initiative is to inspire our members to learn, build, and showcase their own projects, excuse me. And this year we'll have really cool events coming up. One is the Cloud Hero that's around mid to late October. Stay tuned for that. We're also going to have a React.js workshop on October 21st. We've invited Arslan Dilwater. He's a great speaker and great, I guess, a React.js tutor for things. So definitely look to our channels for that. And we're going to have some really cool machine learning workshops coming up. Projects this year. So we definitely want you to showcase your own projects that you are passionate in building and creating yourselves. And there's also a great opportunity to participate in DSC's annual solution challenge, which will have more information in the in January next year as Google Developer Groups releases more information. If you do want a quick, I guess, overview of what that event is, you can go to our previous October info session video. I've linked the solution challenge playlist and videos in the comment section or the introduction. And we have a Git repository for this specific workshop. This is going to be reviewed in the later slides. So, Git started. What is it? This is an introduction to Git version management. I want you to be familiarized with Git, this useful tool where you can commit, push, pull all of your codes. And we've created a specific organization, specific repository for this. So definitely go to that link, fork our projects, and then follow along the tutorial, do the cool things as we do. So a formal name for Git would be Global Information Tracker. That being said, you can do really cool things with Git. You can definitely collaborate with your team, work with your friends on certain projects, and then see where each of you's progress is at. And then you can do something as cool as a time travel. Yes, we're not, it's real. We can do time travel with Git. And documentation for sure can keep really cool things on the record and have them organized using markdowns or what are there any other, I guess, preferred ways to organize your texts, and much more to that. So GitHub is one thing we want you to be able to differentiate with Git. GitHub is a platform where you can safely save all your codes, your changes to the codes, and then any of your teammates' changes on it. You can do so with using Git. And it's pretty similar in comparison with using Google Drive, which I believe most of us are using nowadays. So with the Google Drive, you can save your files, and anyone who has access to your drive or your shared drive will have access to the files within the files that you saved or added. And with a Git repository, you're saving your code files to GitHub or any other repository platforms like that, and then you can redistribute them and make the general public or anyone with a GitHub account or a GitLab or anything like that have access to it. So this is what we call an open source platform. And this workshop is going to cover the following 5 parts. The first one will be staging and committing. So a basic overview of what staging and committing is when you have your original files untouched and then you make revisions to any of them or multiples of them. For example, this file that turned from gray to orange is the one that you made changes to. Maybe you're adding more functions to it. You are doing your own branch of explorations, and then we're saving that to a new pile of files. And what staging and committing looks to Git is like you have this initial save that's represented as a node here. This initial save is whatever you had originally, and then after you make your revisions, that's saved as a new file or added file. Um, Afterwards, whatever file, other extra files you added to it, it changes color again, which means there's new changes, and Git is notified with that. And you commit all of your changes. You're satisfied with your code. You're committing, basically informing Git that you want this version of your codes to be saved or recognized. So that will be indicated as a new node or called new save. A funny thing that people say is like you replace bad code with more bad code, but I would like to think, if you can replace bad code with more good codes, that's what we call, productive. So hopefully we're doing that. Mm, yeah, so for each new save, you're gonna have this node that's associated with your changes. And what it looks like to Git is basically you have these snapshots from the initial commit to your second commit. Indicated by your commits. Git will know what snapshots to save to itself, so that next time you access it, it's bringing you to the head or the most recent commit, which will be the fifth commit in this case. And the branches, I am going to invite my brilliant collaborator, Gladys, to talk about this topic. Gladys?
Um, Hi. So I'm Gladys, as Vicky said. I'm just gonna pick up where Vicky left off here. I'm gonna talk about branching. Branching is really helpful when you're working collaboratively, like in a group, or maybe yourself when you're working on like a bigger project.
Ooh.
And it's a very big part of using Git. People always say like branching strategy is they would call it like an art of using Git. So it's a really big part of using Git when you really get into it. And I'm just gonna explain how branching works in this hypothetical scenario. So let's say that you and your friend are both working on like this one project. And Vicky, can you go to the next slide, please?
Yes.
Thank you. Yeah, so it already has two commits in it, M1 and M2 for master branch, and then there's like this new feature that you really want to experiment with, but of course you don't know if it's gonna work out, and you don't know if it's gonna fit the actual project. You just want to experiment. You don't want to contaminate your repo with like this unstable code. So what you'll do it's that it would be great if you and your friend can go on separate ways and explore, right? And Git lets you do that by creating a new branch. And how you're gonna do that is that you can just simply type in git branch with a branch name. In this case, it's a new branch, so you can simply type um, git branch new branch in your terminal, and then it's gonna make you a new branch, and then you can git checkout um, new branch, which git checkout is the command that lets you switch in between branches, and then you will be on the new branch.
Mhm.
But this diagram of git history is gonna look the same for for like a while until you have completed the first commit. Yeah, that will be it. And from there we can just keep pushing forward the history, working on the new feature, and meanwhile your friend might be working on the actual product, fixing a few bugs, maintaining the functions. And then uh, I have to say that like whatever you're doing on the new branch and whatever your friend is doing with the master branch, like nothing is so whatever you do on the new branch won't affect the master branch and vice versa. So your code on the new branch, as I said, your friend fixed a few bugs. Your code will still have the bug on the new branch, and your friend won't get to test the new feature until you at some point bring the code on your branch back to master. Your process we call merging. So let's say eventually you think the new feature looks pretty good. You think it will fit the project you want to brand it master. What you'll do in Git's terminology is to merge the new branch to master branch. And that is accomplished by typing into the terminal git checkout master and git merge new branch. So let me explain detail what happens here. Um, so we already said like git checkout lets you switch between branches. So Vicky, can you go back to the previous slide, please? Thank you. Um, yeah, so before checking out master, you were at a new branch. And after checking out master, you'll be back in master at M3, which is the newest commit master. And from from here, I said you can type git merge new branch, which will combine M3, which is the newest commit as master, and N2, which is the newest commit and new branch, and then form a new commit at master, which we call M4 here. And that new commit is on master because we first checked out to master and then merge the new branch to the master. So now master has a new commit, while the new branch is untouched. So you can still go back to new branch and still find all your data there and keep working on new branch. Maybe add a few more commit to it, like N3 and N4 and so on. It's just M4 is going to have going to be the combination of M3 and N2, and your friend can keep pushing forward with M4 as well, with maybe the future M5 and M6 and so on. And that happens pretty smoothly if you and your friend didn't touch the same block of code. Maybe like, but in case that maybe you delete this file while your friend was editing it, or you both have touched the same line of code, Git won't let you merge it. It will run into something we call merging conflict, and it will stop you from merging the code. And that when that happens, you'll just have to stop, take a look at the part that you both want to change, and argue with each other.
Yes, I would say I would argue that is the most interesting part coming up. That's the interesting part coming up with using Git, is when you touch perhaps the same parts of the same files, and then Git realizes that Git is like, whose version do I keep? So you have to manually select or pick one, or figure out a way to maintain both functions and then without causing Git too much confusion. Um, yeah, anything
Yep.
you want to add for merging?
Core collaborative working. Oh, also one more thing, please. There's also a command called git rebase. I'm not
Mhm.
gonna talk about it here, but like people always debate or discuss um and whether git merge, like
Oh,
which
yeah,
one of the two commands, git merge or git rebase, which one of them is better.
there's a
They're kind of similar in function, like um but they have different effects.
mhm.
As I said, I'm not gonna talk about it here, but like I
That's
strongly
okay.
recommend.
Mhm.
Yeah, that's it. And now give
That's actually
the
a really
floor
good
to Eve.
point I think you brought up. So for definitely there's a controversial nature of Git rebasing and then Git merging, like whether what versions of things, what version of commands do I want to use with my, specific project. I would say that differs at case by case and would definitely advise you to look into more documentations on commands specifics. And basically, with Git rebasing, there's a certain kind of remember we talked about you can do time travel earlier on with Git. This is like you're rewriting the history. Um, you're simplifying this Git tree. So notice how from each node we have these branches. So you can I guess kind of think of it as a tree. With rebasing, you're alternating the branches. You're making it, it's not the natural growth or something like that. So definitely look into the documentation before doing so. And we will have some more details in our repositories, introduction and docs. So look out for that too. And other than that, Gladys, wonderful job. I have not heard of anyone explaining merging um, and branching, that well. I think it's a really good analogy to think of, working with your friends or something like that. And without further ado, I'm gonna bring us to reverting, which is the oh my gosh, I messed up. What do I do now? So reverting is a process that's dedicated to situations where you feel like I need to change this. I can't keep this. I can't keep working on this project with the code or changes whatever things I have right now. Um, and now we're officially rewriting histories. It's dangerous. We're entering danger zone now. So warnings for y'all. Something we can do is, for example, if with your recent commit you changed something that you probably don't want to touch, and then you want to go back to the snapshot or the node, the one last the previous one commit. You can do what you can do is type in git reset. And then with that, you have a flag option. So flag option is always prefixed with the dashes, and you can do with a hard reset versus a soft reset. We have more explanations in the repository docs, but basically you have the old commit ID followed by that. That will reset your commit, and then you'll do git push with dash F. That will give it an F flag. Actually, for hard, you have two dashes prefixing that, and then for F, you only have one dash preceding. And then you have the remote branch name, and your I guess the branch that you're on, the branch name of the ones you're on. Some people say that they have problems if not put in exact formats like this. So it might be good to just do that. Again, these can be found in the notes section of our docs. So anything else I can want to talk about? Okay, there's also git command dash dash amend. You can simply add the commit messages without altering the commit, without altering the commit itself. What this command seems to get would like a brand new commit, since it's not editing the original commit, but more so like replacing it with a new commit. So that is to say, if you have a commit, you changed, I guess, instead of like adding a new method, what you did was like you made changes on the original methods, and you want to change the commit messages now. Git commit dash dash amend will be a useful command to do so. Yeah, and glad to talk about rebasing. I think that's pretty much I want to cover with reverting. We have some really cool animation effects. I want to go with this. So with reverting, now we have two branches: the master branch, the new branch, and their merged commit on M4. You want to go back to, I guess, you don't want this M3. So yeah, with the commands, you take M3 out, and you sort of kind of just like rearrange them in this way. So this is what git pull looks like. Git pull is probably one of the most fundamental commands we'll run into. With the git pull, you remember in branching slides, we have the new branch and the master branch indicated by green, and new branch is like the orange part. Of course, it doesn't always have to be a new branch. You can name it very creatively. You can name it with your name if I guess, working on teams, but I would prefer naming it with more descriptive names, such as, if you're doing something with Swift UI, you name that branch Swift UI. This is one example. So what you're doing is like um, grabbing whatever you have at this node right here you have to this new branch and start working on that. That's what a pull command can do for you. For a push command, it is more like where you're at this branch and then you make some changes. You're pushing to the repository you want to save your changes. That's using git push. And remember to commit before you push. Tested by real life experiences. Not going to mention any names. And then merge is when you have two branches. You want to put them all together. Remember, this is like a quick review, so don't forget to resolve your conflicts. And again, push that when you make new changes. So don't forget to follow us on these social media platforms. We are on Twitter. That's the leftmost QR code. And the middle one is our official DSC event platform. So you can view a grid line of, you have a grid view of what are upcoming events and some of the events that happened in the past. On the rightmost is a sign up form. If you are at UW interested in development, please make sure you fill out this form to be, to have this more formal membership, and we can reach out to you, have ways to contact you in a sense. So, just scan these QR codes, very handy dandy. And that will be it. Thank you for coming to our Get Started workshop.